Just sharing the screen. Can you see my student?
Yes.
Yes, sir.
Yes,
My sound is okay, I hope.
Yeah.
very okay.
Okay, nice. Okay, nice. I am muting all my students. Hopefully you have studied the previous class lecture. Please try to interact me in the chat box, and please give your roles. Everyone give your role in the chat box. Okay. Okay. So they will join, no problem. We have waited a lot. I hope they will join soon, the other students. And everybody give your role in the chat box. Okay, hopefully you can see. So basically we are starting the diodes. We're starting the diodes, and the yesterday, or probably the last class, we have seen the uh, application of diode. We have seen the half wave rectifier, where the AC signal, the AC signal, both positive and negative part, we saw that the half wave rectifier can only give the output in the half cycle. Okay, that's why it is known as half wave rectifier. But today we will see a full wave rectifier, where that circuit can transfer the full cycle of AC. Okay, that cycle, that circuit, that full wave rectifier can transfer the full cycle, both the positive cycle and the negative cycle in the output. So basically you can see that this is known as full wave rectifier, and today we will see the bridge network. There are two types of full wave rectifier. Today we will see the bridge network type. Next class we will see the next type. Okay, so the first one is that you see that the DC level obtained from a sinusoidal input can be improved 100%. That I have already told, that the full cycle using a process that is known as full wave rectification. The process is basically known as full wave rectification. Please give your role in the chat box, everyone. Everyone give your role in the chat box. So basically it will be something like that. You see that this is the input circuit, this is the input, and this is the full wave rectifier circuit. When we will give this input to the full wave rectifier, when we'll give it input to the full wave rectifier, it will give the output something like that. You see that everything is in the output. This is first positive half cycle, this is also the negative half cycle. So everything in the positive side, there is not in the negative side. Everything will be in the positive side in the full wave rectifier circuit. That what I'm trying to say, that in the positive cycle and the negative cycle, both will be in the full wave rectifier output. But whatever was in the half wave, it was only the half cycle. So that is the difference between half wave rectifier and full wave rectifier. Okay, so let's see the circuit first. So this is the full wave rectifier circuit, my dear student. This is the full wave rectifier circuit. Well, just see that there are 4 diode configuration. This is one D1. That's why we have represented D1, D2, D3, D4. This is D1. This is D2. This is D3. This is D4. There are 4 diode configuration. There are 4 diode configuration, and in between there is a load resistance. In between there is a load resistance. So this is the full wave bridge rectifier. This is the bridge rectifier circuit. This is also known as Western bridge. Probably you have listened that term, Western bridge configuration. So there are 4 diodes, and in between there will be a load resistor. And across the diodes, we will give the input. We will give the input VI, that will be VI, and across the resistor, it will be the output. Across the resistor, that will be the output VO. Okay, it will be the output VO, and this is the input. The VI. This will be both the positive cycle and the negative cycle. Both the positive cycle and the negative cycle. So this is the basic full wave bridge rectifier circuit. Pardon me. So let's see how it works. Let's see how it works during this full cycle. Okay. So in the positive cycle of input voltage, how it works. Let's see. Basically, this will be the input. At that time, this will be the input. This is the positive cycle. Okay. This is VI. This will be the positive cycle. 0 to T by 2, the half cycle. That's why the first half cycle, that's why 0 to T by 2. It is given that 0 to T by 2. This will be the input signal. So you know that, and in the positive cycle, this will be VI. This is positive terminal. This will be the negative terminal. Okay, this will be the positive terminal. This will be the negative terminal. So the current will flow. We always know that the current starts to flow from positive terminal. The current starts to flow from positive terminal. The current starts to flow from here. So it will go the current will go here. When the current will go here, it has 2 paths. One has this path. One has this path. It has 2 paths. It has 2 paths. Let me uh, make it a little bit bigger so you can see. I think now you can see better. So basically it has 2, but let me clear all my drawing so I can understand. So this is the positive terminal. This is the negative terminal. Okay, and the current will start to flow using this direction, the clockwise direction. The clockwise direction, the current will start to flow. So when the current will come here, this point, it has 2 paths. One is this path, one is this path. So there are 2 diodes. Number 1 diodes. Suppose this is number 2 diodes. Okay, 1 diode and 2 diode, and we will discuss 1 and 2 right now. You see that when the current starts to flow, when the current starts to flow, when the current starts to flow, it gets 2 paths, and there will be 2 diode. Okay, so when the diode suppose in this direction, suppose we are talking about one diode, first diode, number 1 diode. When it is going in the 1 diode, it will be plus, it will be minus. And you should know that now this is N is plus and P is minus. So this is reversed biased. So this is reversed bias. So reversed bias, we all know that there will be no current flow. This will be open circuit. This will be something like open circuit, something like this. This will be open circuit. Okay, so this will be open circuit, so there will be no current flow. There will be no current flow. There will be no current flow. But what about that? What about the diode 2? But when it will try to move to diode 2, it will be plus. The diode 2, it will be minus. So this will be forward biased. So this will be forward biased. So this will be shorted, this will be like shorted line. So the one diode will be reversed biased, the two diode will be forward biased. So that one diode in this line, there will be no current flow. In this line there will be no current flow, it will be open circuit. The current will flow, the current will start to flow here, and then will flow within the, let me draw one more time. The current will come this point and then will flow within the this point. Okay, so the one number diode is forward bias, the two number diode is for sorry, one number diode is reverse bias, the number two diode is forward bias. Now the current has come in this point, the current has come in this point. Okay, so it has two paths. Now it has two paths. One is this path in the resistance path, one is another diode. Suppose this is diode number 3, this is diode number 4. So it has two paths. This is 3, this is 4. One is according to the resistance, and another path is the diode number 4. But when it tries to flow the diode number 4, it becomes plus and minus. And you see that this is the configuration of reverse bias. This is the configuration of reverse bias. That's why the diode number 4 will be reverse bias. So there will be no current flow because this is the open circuit. Because when the reverse bias flows, something like that, you see, suppose this is the diode, and we all know that this is the diode. This triangular structure is P. This vertical line is N. So when it is plus, P is plus and N is minus, this is forward bias. Okay, this is forward bias. I'm writing F. But when the P is minus and N is plus, this is reversed bias. This is reverse biased. So basically the current will not flow in the current will not flow in the diode number 4. Okay, the current will not flow. So there is only one path left, that is, there is only one path left, that is according to the resistance. So the current will start to flow the resistance. So now the current has come this point. So when it flows the resistance, this will be plus and this will be minus. Okay, so there will be a voltage drop in the resistance. Okay, and you all know that these are the ideal diodes. There is no silicon written here, so there will be no voltage drop. So there will be no voltage drop. So the whole voltage, the whole vi will be in the resistance. So now the current has come in this point. Now the current has come in this point. Now the current will start to flow here. You see that this is positive, this is negative. So this is also forward bias, this is also forward bias. So now the current will start to here and also come to the negative. Finally it will be the closed circuit. So basically you see that if I mark, there are 4 diodes, 1 2 3 4. In the when the positive cycle will move, the 1 and 4, these two diodes, this 1 and 4, this 1 and 4, these two diodes will be off, that means reverse biased. And these 2 and 3, 2 and 3 number diodes will be forward bias, and the voltage will be applied in the resistance. Okay, so you see the conduction. So let's see the much more detailed diagram so that we'll understand you more. So see, already I have drawn for you. So you can see that the diode starts from here and go there, and then current will start to flow within the resistance, and finally that, and finally go to the negative side. So this is the current conduction, and you see that as there is no resistance without R, so the whole VI will be across the whole VI will be across the resistance. Okay, the whole VI, the input voltage will be applied in the resistance, and we all know that the resistance voltage is the output voltage VO. The resistance voltage is the output voltage VO. You see that this is the input, this is the input in the left side, this is the input. So the whole input, okay, the top value, the peak value is the VM, the peak value is the VM. So the whole voltage will be applied in the output. So you see that the exact diagram in the output, exact, because there is no voltage drop without R, and we all know that the voltage of R is the basically the output voltage. So the whole voltage drop will be the VM, will be the output. Okay, so I hope you understand the positive conduction. So it is when it is positive, so positive cycle, it works like this, and the whole voltage drop will be applied in the resistance. Okay, so hope you understand. Now we will see, the the negative cycle conduction. Now we will see the negative cycle conduction. uh, Let me clear my drawing. Okay, now we see the negative cycle conduction. That will be something like this. Suppose we are drawing the, this is positive cycle, this is negative cycle. Okay, now we will see that this part, now we will see this part. Okay, the negative cycle, we will see that how negative cycle works. So basically you see that in the positive cycle, this will be the sign, now the negative cycle, the sign will be negative, the upper side, and the lower side will be positive. Okay, just the reverse, just the reverse. So you can understand, you can really understand that now the current will start to flow from here. From here the current will start to flow, because the current always starts to flow from the positive side. Okay, so from the positive side the current always starts to flow. So when the current reaches in this point, the current reaches in this point, you see that when the current reaches in this point, it has two paths. Suppose this is diode 1, this is diode 2, this is diode 3, this is diode 4. Okay, so it has four paths, it has it has four diodes. So when it reaches this point, it has this direction, this path, and this path also. So which path it will flow? Okay, when the current will start this at this point, the lower point, it has two paths. Which path it will flow? You see that the diode number 4, this diode, the diode number 4 is in positive biased or forward biased. The diode number 3 is in reverse biased. The diode number 4 is positive biased, the diode number 3 is reverse biased. So basically it will flow within the diode number 4. It will flow within the diode number 4, because this is the forward biased, so it will flow. So when it will come to this point, now it has two paths. One is according to the resistance and one is according to the diode number 2. But you see that the diode number 2 is forward, not forward bias, it is reverse bias, because this is positive, this is negative, so it is reverse biased. I hope you know that what is forward bias, what is reverse bias. That's why I have given so many importance on that, and I hope you studied. So again, I'm drawing for you that suppose this is the diode, this is the P, this line is N, so this is diode. So when it is negative and N is positive, it is reverse biased, it is reverse biased. Okay, Okay, it is reverse biased. So you see that the diode number 2 is reverse biased. So it will, the current will not flow within the diode 2. So the current will flow inside the resistance, and you can see that in the both positive cycle and the negative cycle, in the both positive cycle and the negative cycle, the current direction according the resistance is same. You see that in the positive cycle also, the current flow in this direction, the current flow in this direction from right to left. Similarly, in the negative cycle also, this configuration is such like that the current always flow inside the resistance in the same direction. So when it will flow come in this point, you see that this diode number 1 is forward bias, because this is positive, this is negative, this is positive, this is negative. So when it is forward bias, the current will flow there, and finally this point. So this is the conduction of during negative cycle. The diode number 2 and diode number 3 is off now. Now 1 and 4 is on. So you see that in this 4 diode configuration, 2 diodes are on in the positive cycle, and the opposite 2 diodes are on in the negative cycle. So we always get the voltage in the resistance. You see that that is the purpose of full wave rectifier, to get the voltage both positive cycle and a negative cycle, and we get the whole voltage, whole input voltage vi according to the resistance, that means output vo. Okay, so that is the conduction process of negative cycle during. So let's see a more detailed diagram that will help you. This one, uh, suppose this one. Okay, so as we have already seen, the current will start to flow from here and flow here, and according to the resistance, and finally this will be the current flowing direction. So this resistance, this diode and this diode will be for reverse biased. So you see that the whole voltage, there will be no voltage drop. The whole voltage vi will be according to the vo, the resistance. So this negative cycle, okay, this negative cycle will be now in the positive side, in the positive side. Why in the positive side? You remember, let me clear this, then you can understand. You remember, in the positive cycle, this was the plus sign, this was the negative sign for voltage, output voltage. In the negative cycle also, this is the plus sign, this one the negative sign. So the current flow is always in the same direction, current flow is always in the same direction. Okay, so that's why the voltage drop across output, the voltage drop across output is always in the same side. So that's why in the negative cycle voltage, it has turned into the positive cycle. So basically this circuit, you see that we all know that in the uh, you know that in the AC voltage there is positive and negative voltage, but in the DC voltage, okay, the whole voltage in the positive side. That's why you see that this circuit is basically used for AC to DC conversion. AC to DC conversion, this circuit has been used, because every voltage, whole voltage is in the positive side. There is no positive and negative cycle, okay, in the DC voltage. So there is all in the positive side. The first cycle is for the positive cycle, and the second cycle is the for the negative cycle. So we get the whole voltage, whole AC voltage, whole the positive side and negative side in the output. That's why it is known as full wave rectification. That means we are converting the full cycle, full AC cycle, both the positive cycle and the negative cycle in the output. So I hope you understand properly. uh, let's see what is left in the next 2 pages. Now it will be the effect of silicon diode. Okay, now it will be the effect of silicon diode. That the discussions we have done recently, that was for ideal diode, but for silicon diode, same process, same thing. We all know that only one thing change. In the normal diode, the voltage across diode VD, in the ideal diode, that is zero. That is zero. But for silicon, you all know that that diode voltage VD becomes, and we will discuss every time, every day we are discussing this. That is 0.7 volt. That is the only one difference while silicon diode. Okay, there is only one difference while silicon diode. So now we will consider, in the suppose same thing will happen, same conduction will happen. We'll just consider the silicon voltage, the VD equals to zero point 0.7 voltage. So suppose suppose now the voltage output will be like that. We'll calculate that. Suppose this is positive, this is negative sign, this is positive, this is negative sign, this is positive in the output VO, this is negative sign, this is positive, this is negative sign. Now we'll take the KVL in this loop. Take the KVL. So we are taking, suppose we are taking the second sign. So now we'll take the second sign. So it will be plus VI, plus VI. Then we will take the second sign of VD. So it will be minus VD. You see this one, the second sign. It will be the minus VD, the minus VD. Then we will take the second sign of V output. The second sign will be the minus. So minus VO, minus VO, and then we'll take the second sign of minus VD. So minus VD equals to 0. So we need to find out the V output. So basically the V output becomes VI minus 2VD. VI minus 2VD. So as we all know that the peak voltage for our input is Vm. So basically the V output will be the Vm minus 2V. So 2VD is for two diodes. We all know that in each cycle, two diodes are forward biased and two are open. So for two forward biased diode, we require two voltage, 2VD, 2VD, one VD equals to 0.7. So 2VD will be 1.4 volt. Okay, 1.4 volt for 2VD. So this is the effect of silicon diode. In the normal diode, it was Vm. The normal diode, it was Vm, but in the silicon diode, it is Vm minus 2 diode voltage, because two diodes are on. So that's why it will be 2 VD. Okay, it will be 2 VD. So I hope you understand the effect of silicon diode um, in replace of the ideal diode. Okay, so this is the diagram, the output diagram, how it changed. We have already shown that. Suppose this is the input voltage graph. Shit. Let me draw one more time. Suppose this is the input voltage. Okay, this is the input voltage, and now we have silicon diode 0.7 volt. That's why we need to draw a line. We need to draw two line, both in the positive side, both in the negative side. You see that in the ideal diode, the output starts from the zero, but in the E side, uh, what I'm trying to say, in the silicon time, in the time of silicon, it will not start at zero. So it will, this 0.7, at this time, it will be no conduction. After that, it will be the voltage drop. Similarly, the middle one will be also no voltage. After that, there will be a voltage, and the peak voltage will be Vm minus 2 Vd. Vm minus 2 Vd. In the ideal diode, it was Vm, but for the silicon diode, it was Vm minus 2 Vd. So there will be some offset. We have seen in the half wave also, there will be some offset due to the silicon voltage. Due to the silicon voltage, there will be some offset in the both starting and ending purpose. And the top voltage, the peak voltage will also not remain as Vm, it will be Vm minus 2 Vd. So that is the change. The main change is the peak voltage Vm minus 2 Vd. Okay, and next, the average voltage. In the last class, we have seen the average voltage for half wave was 0.318 Vm, 0.318 Vm. Okay, for the half wave, and you know that the half wave, it has only one side. Now the full wave has two sides, so basically we'll multiplying with 2 into 0.318 Vm. So the voltage, the DC voltage or the average voltage will be in the full wave 0.636 Vm. Just the multiplying with the half wave, just the multiplying with the half wave with 2. Okay, we'll get the 0.636 Vm. But for silicon diode, this is for ideal diode. This is for ideal diode. But for silicon diode, we have to subtract Vm minus 2 Vd, because there are two diode voltage. There are two diode voltage. That's why we have to subtract the minus 2 Vd. Let's see what is next. This is the PIV rating. The PIV rating is not so important, but we still discuss. PIV rating is the peak inverse voltage, the maximum reverse voltage we can apply to a diode. The maximum reverse voltage. Okay, so basically, when the positive cycle starts to flow, this diode is forward bias, this diode is negative bias. Okay, this diode, so the whole voltage or reverse bias, the whole voltage is applying in this diode, okay, in this diode. So the maximum voltage the diode feel, that is the peak voltage Vm. So the positive peak voltage, peak voltage is the PIV rating. So the maximum PIV, the maximum voltage we can apply, that is the Vm, the peak voltage of the positive cycle, because that is applied in this diode number one, and it is reverse bias. So it is same like half wave rectifier. The maximum peak voltage is the the peak inverse voltage for the diode. So that was today's study. I hope that you understood. Uh, let me stop the share and come back to all of you. So that was today's class, my students. I hope that you understood everything. And I try to draw by my hand, and that's why I am not using the book anymore, because when I will draw, I can give you much more detail, because in book it is not so much detailed. So when I'm drawing the diagram, everything, it is giving much more detailed diagram. So I'm unmuting all. If any students have any question, he can ask.
Sir,
Everyone is unmuted. Yes, sir. Who?
Amir.
Okay.
Amir, yes, tell Amir.
Sir, I wanted to ask you one question, and that is, let's say I wanted to make like a project, a small project,
Okay.
by using a diode. So, what's our interest if we connected the diode as a reverse bias? What is our interest?
if we connect the diode in the reverse bias,
Yes.
there will be no voltage. Okay, there will be no voltage in the output. Suppose you build a series circuit. You build a series circuit.
Yes.
Okay, suppose something like that. A very very small fan, DC fan, 3.5 voltage, or
Yes.
LED or something you can consider LED,
LED. Yeah.
LED lights. Okay, so
Yes.
you connect a DC voltage or the battery with
Yes.
series with diode. Okay, and with
Yes.
LED. Interesting thing is that
Yes.
when the diode, you connect the diode in the reverse bias. Okay,
Yes. So
when you are
what?
conducting the diode in the reverse bias, the LED will not on, or it will be not, it will be off. There will be
Yes.
no light in the LED. But when you will,
Exactly.
yes, when you will connect the diode in the forward bias, that means that now the circuit is closed. You will see that the LED voltage or the LED will be on. Okay, so
Exactly.
in the reverse biased time, if you connect the diode in the reverse bias, the circuit will be open. We all know that in the open circuit there will be no current flow, isn't it?
Yes.
Yes. So basically, if when the reverse bias, there will be no current flow inside the circuit. So this will be open. So whatever the load you what I'm trying to say, whatever the load you connect with the reverse bias diode, it will not get the voltage.
Yeah. I also am interested. Uh, how can we? Yeah. That's how I was interested.
Okay. So basically, it's a very popular project. Is you can also search in the YouTube that a very popular project is conversion from AC to DC. Okay, this bridge
Yes.
rectifier. There are four diode. You take four diode and uh, connect with the AC line. Okay, but it's very risky. Don't try it, without any kind of precautive measure. You connect in
Yes.
this four line and convert into the AC to DC. The DC voltage, the AC to DC conversion basically happens using this diode. It's very popular. You can just search that AC to DC using diode. Okay, you will see.
Okay.
You will see.
Okay. Thank you.
So I hope you understand. I will give the lecture as soon as possible. So my students, are you enjoying these handwritten notes, or the slide was better?
এইটাই ভালো স্যার
I think this one is better. This hand note is better. I always try to, much more clear way, much more, detailed way, so
Exactly.
that is it helpful for you all?
Yeah, it's very helpful. So good.
Yeah. Okay. Please
So perfect.
try to study. Please try to study, because every day we are taking a new topic. Every day we are taking new topics. So try to study, because I am giving the class lecture. I am giving the everything, as soon as possible within that day. So please try to study. So we'll meet in the next class. So until, uh, be safe, everyone. Okay.
Okay.
Okay.